Hello, everyone. Honey, today is Saturday, May 23, 2026. And I'm your host, Sano Ai. I am so excited to be here with you today because I have a super interesting trending article from the archive to share with you all. It is about something that sounds like pure magic, but it is actually cutting-edge technology. The title is Live Music Diffusion Models, Efficient Fine-Tuning and Post-Training of Interactive Diffusion Music Generators. The crow is Daxbox CVI board 605.22717 million. It is long, right? But do not worry. I am going to break it down and make it super easy and fun to understand. So, what is the big problem this paper is trying to solve? You imagine you are a musician, or just someone who loves making music. Lately, artificial intelligence has gotten really good at generating whole songs, which is super cool, but there is a catch. Most of these advanced AI music models, especially the ones called discrete autoregressive models, were absolutely massive, like they required during industrial computers to run, taking up over 40 gigabytes of memory just to function. That means normal people, like you or me with our regular laptops, cannot just use them in real time to jam or perform live. They're offline, meaning you tell them what to do, and then you have to wait for the whole song to bake. But music is alive, right? It is interactive. Musicians want to play with the AI as if it is a bandmate, creating music on the fly. What is where this paper comes in? The researchers investigated a different type of AI called diffusion models. You might have heard of diffusion models for generating images, but that can do audio too. The cool thing about audio diffusion models is that they are much smaller, and they can easily fit on a consumer gaming laptop. However, diffusion models are not naturally built for streaming live music. They usually need to look at the whole song backwards and forwards to generate anything, which makes them too slow for a live jam session. So the researchers did something brilliant. They figured out a way to slightly modify these diffusion models, creating what they call live music diffusion models. Well, crumbs, they changed how the model looks at the clean past music and the noisy new music it is trying to create by putting a special mask on the attention mechanism, which is how the AI focuses on different parts of the data. They allow the model to cache, or temporarily save, its memory. It makes the whole process incredibly fast, recovering the efficiency of those giant models for running on your everyday gaming laptop. Now, let us compare this to other technologies. Before this, if you wanted high-quality, text-controlled live music generation, you needed a massive server farm. The older autoregressive models, while amazing, are just too heavy and expensive. On the other hand, traditional diffusion models are small, but super slow, because they recalculate the whole context window over and over by introducing this black-wise caching and a new training method called falsifying. For the researchers made LMDMs both small and lightning fast. Our fun is really cool too. The LCA stay on track over long periods of time, so the music does not turn into weird noise after a minute. It does this without needing complex reward systems, which makes it much easier to train. So, how can this technology be applied to our everyday lives? Let me give you 3 specific application examples that are just mind-blowing. First, imagine a text-to-audition LibG setup. Let us say you are throwing a party, and you have this crumb running on your laptop. You can type in driving energetic Adam, and the AI starts generating awesome dance music in real time. The day, the vibe of the party changes, and people want to chill. You just smoothly type it relaxing jazz piano. Then the AI seamlessly transitions the live music from Adam to jazz. It rotates the prompts on the fly. Second, Well, let's talk about generative delay effects for live musicians. This is actually something they tested in the paper. Imagine a saxophonist playing a solo on stage. Their saxophone is plugged into a laptop running the line, and as they play, the AI listens to the melody in the loudness, and it generates an accompanying sound that plays back just a second later. And it is not just echoing the saxophone. It may answer back with a deep synth bass, or even the sound of a singing a humpback whale. Yes, they actually trained a model on whale songs. The AI acts as a creative machine, throwing out new ideas based on what the human just played, leading to a totally unique, improvised live performance. Third, think about dynamic video game soundtracks. Usually, game music is pre-recorded, and it just fades between different tracks depending on what you are doing. But the LMDMs, the game could generate the soundtrack completely from scratch, in real time, based on your gameplay. If you're sneaking around, the AI generates tense, quiet music. The moment you are spotted by an enemy, the game feeds a new prompt or audio stem into the LMDM, and the music instantly explodes into an intense battle theme, perfectly matching your exact actions. Because it is lightweight. It runs right on your gaming console or PC without lagging the game. It is just so exciting to think about. Technology like this really bridges that it takes these powerful tools out of the big tech labs and puts them right into the hands of kids in their bedrooms. Indie game developers and live performers. It turns AI from a simple jukebox into a real, playable instrument. Well, I hope you found this as fascinating as I did. AI is changing the world so fast, and it is super cool that we get to see it happen. Thank you so much for tuning in today. And I will catch you all next time with more awesome tech news. Bye for now.